Hi everybody. Thank you for the introduction, Pearl. And my name is Baruch. I'm developer advocate with JFrog. You should follow me on Twitter at jbaruch. I'm a very interesting guy, a lot of interesting tweets. With that, let's see what do we have here. So today we're going to do a quick overview of JFrog Artifactory, and we're going to talk about how Artifactory serves as your system of record and why it is important, especially when we are working with Docker. We're going to talk about Artifactory and our special integration with Jenkins, with Jenkins in general, and Jenkins pipelines, Jenkins 2 in particular. And of course, we're going to see a demo of how that all works together. So before we start, let me ask you to kind of calibrate my pace and the content. What is your usage of JFrog Artifactory? I'm going to launch a poll that you should see on your screen now. And please go ahead and vote. Okay, now I can see that it actually works. Just a couple of more seconds. I see that most of you already voted. Okay, so most of you already voted, probably whoever wanted to vote, and I will show the results with you. And you can see here that the majority of you use Artifactory with multiple packaging types, and I'd assume you are in Docker webinar, so you use Docker and probably something else as well. Right, and most of you use build integration, which are great news, and this is what this webinar is about. I hope I will be able to give you some more advanced stuff and tips that you didn't see, and kind of make your build integration even better. Some of you use open source, some of you use Pro, and a decent amount on enterprise as well. So I think we have a good distribution of users here, and I hope this webinar will be useful for all of you. Let's start digging into how you build your software. Again, that's a very high-level diagram that goes through all the life cycle, and we will use some of it. We will talk about some of it today. So, of course, every software development begins with developers writing code, and when they write code, they reuse open source or in-house closed source components, which come from a variety of build tools and dependency management that they are using. Today we are going to see an example of a Java build that was built with Maven or Gradle, but it also can be any other development language such as Ruby, Python, JavaScript, .NET, C#, or Objective-C, whatever. Any kind of software development will include declaring new dependencies, either in the build tool or using a standalone dependency manager. Once some chunk of development is done, the developer runs the build on their own machine to check that the code actually works. And then the dependency management, either built in a build tool or separate, kicks in and tries to bring the new dependencies that we declared. And those dependencies are fetched from remote repositories. In our case, this remote repository will be Artifactory. This Artifactory either already have this dependency as cached because someone used it previously, or it's a completely new dependency. In this case, Artifactory will go to a matching remote repository or registry and will find the needed component there. It can be a JCenter or Maven Central for Java development. It can be NPM registry. It can be Docker registry, of course, or rubygems.org or any other remote dependency that we are talking about. Once the dependency is there in Artifactory, it will be, of course, returned to the original dependency management request, and the build will successfully finish. Once the build is finished, the developer commits the code to version control, and this is where the CI server kicks in, what we are going to talk about today, right? So we're going to talk about Jenkins today, but it doesn't matter which CI server it is, they all kind of work the same. They take the code from the source control and build it. So they build it using this exactly same build tool that we saw in the first step. And this build tool and dependency manager will try to do the same the same operation that was performed on the developer machine. So they will obviously need the same dependencies, and they will be downloaded from the same repository, in our case, Artifactory. Now, this time, the remote repositories won't be necessary because everything is already cached in Artifactory. So the dependencies will just be downloaded from Artifactory directly, and the build will be successful. Once the build is successful, the build artifacts, the module artifacts, are deployed to Artifactory. Now, with those artifacts, there is something else that is deployed, and that's the build info. Build info, or what we call it the bill of materials, is all the metadata that we collected during the build in the CI server. So we gather all the metadata and about how this artifact was built, and we attach it to the artifact itself, and we deploy it to Artifactory. And once this is done, the build is finished, and then we start with the promotion pipeline. So promotion pipeline is about moving artifacts from one repository to another, adding more and more metadata. And this metadata will be, during the promotion pipeline, probably a quality oriented, right? We run different tests. It can be unit tests, integration tests, performance, it can be security, like penetration tests, behavioral tests, manual QA. Any of those promote artifacts from one repository to another and contribute additional metadata to it. And this metadata is, again, attached to the artifacts in the artifact repository and actually belongs to these artifacts once it is done. Once the promotion is done and our artifacts are ready to go to production, there can be two types of artifacts. Ones are deployable artifacts, and those artifacts which are deployed to the servers on your control, whether it's bare metal or virtual servers that are in your data center, or it can be serverless architecture in the cloud or any of the cloud providers. And then you use the appropriate tools, Docker, obviously, but also any other kind of provisioning tools like Chef, Puppet, Ansible, whatever makes sense to you, and you deploy the software to production servers. Or other type of software are downloadable software. And this is software that you make available for download. It can be for human end users to download, like desktop applications, or it can be software that downloaded by devices and machines, IoT, any kind of device. In that case, your software won't be deployed on your servers, but instead will be available for distribution. And here JFrog have another product which is called JFrog Tray, which is a distribution platform that your users can download from. And if you are interested, we occasionally do webinars about Tray and how this distribution hub can power the data center of the download center of your organization. That's out of scope for today. So this is the big picture, and today we're going to speak about a part of it, which is CI server integration with the software that you build, and with some accent on Docker. So this is kind of the part that we are going to talk about. And I mentioned the promotion pipeline, and I kind of explained how it worked. And now the kind of the same process, but just in a little bit different diagram. This is a great diagram from Agile ILM book, which I highly recommend, written by Michael Hutterman, and it explains how the promotion pipeline works. As you can see here, we build our software once, and once the software is built, it is promoted from one repository to another, from one environment to another, by passing what are called the quality gates. And those are the QA procedures that I mentioned in the previous slide, like integration tests, manual QA, behavioral tests, system tests, etc., etc. Each successful test promotes the artifact from one repository to another, attaching more and more metadata to it. We're going to talk about Jenkins today, and Jenkins pipeline in particular. So again, a short poll to see how what is your usage of Jenkins. So let me launch this one. Again, a couple of seconds for you to vote. Okay, so I'll share the results with you. Most of you, 73%, using Jenkins 2 with pipelines, and that's perfect because this is what this webinar is about. And some of you already familiar with Jenkins pipeline BSA Artifactory plugin. So I will again show a little bit of stuff in it. Hopefully it will be interested by whoever used it already, but the majority of you is not, so that's very good, and hopefully you will see some new stuff today as we continue with, especially with the demo. So okay, now Artifactory Jenkins plugin is not something new. I don't know if you can see here the first version. No, I don't think so. But the first version of Artifactory Jenkins plugin was released in 2009, and that's almost, what, 8 years. Today, the latest version is 2.12 something. I don't think that's the latest one. And you can see here that it's fairly popular, tens of thousands of installations. And this is what we're going to talk about. It is in the official Jenkins plugin registry, so you install it by using Jenkins plugin settings. We will see it, of course, in the demo. And before we're going to talk about what it does, let's speak a little bit about Jenkins itself. And what I want to kind of go through is the evolution of the continuous integration tools, and especially the configuration methods for those tools, right? So I don't know if anyone is old enough to remember cruise control back in 2001. That was the first CI server that I used, and the configuration was pages on pages of XML configuration. That was horrible. It was just painful, and people got so tired of this declarative verbose XML configuration that the pendulum switched directly to another direction. And in 2005, when Hudson was released, we went to the completely different direction and had everything configured in the UI using radio buttons, checkbox, and drop-down lists. Right, so we didn't have those huge pages over pages of XML configuration. Instead, we had this nice UI in which we could select whatever we want to do and pick and choose the right options. But it has some limitations of their own. First of all, it's not flexible. What you have in this configuration is what you will get, and there is no way to configure some different aspects of that. And the bigger problem is that it is not versionable. It means that even with those huge XML pages of cruise control, you could put it in probably 2001 in Subversion or CVS and have your configuration saved there and versioned there in a manner that you could check it out and configure a number of CI servers in the particular way. Or if you reset your CI server, you could reconstruct the same configuration easily. With configuration of Jenkins 1, Hudson, and then Jenkins, you didn't have this option. You had to remember which options you checked if you wanted to reconstruct the same setting over and over again. Well, you could find the XMLs that are persisted out of this configuration and version them, but there was no easy and straightforward way to do it. And another problem is that there was no easy way to automate creation of builds. There was, again, some REST APIs that you could use, but it wasn't designed in automation in mind, because you actually had to select those checkboxes and those lists. So those three problems were significant enough to kind of consider Jenkins not DevOps ready, because those three features, and especially versionable, everything should be code, and automatable, everything should be automated, are the essence of DevOps tooling, and without it, Jenkins couldn't stand the competition of other DevOps enabled tools. So the pendulum went all the way back to the code in 2016 with the release of Jenkins 2 with the pipeline plugin, in which we are back to configuration, to our CI configuration as code. Of course, it's a completely different code. It's not XML over and over again. Instead, it's a modern and robust groovy DSL. But again, we have here a code that is versionable, automatable, and flexible, right? So it's still declarative, or it can be. And here you can see an example of declarative pipeline when we still say what we want to build and not how we want to build. It's extendable, and we will see today example of Artifactory plugin extending this DSL with our own constructs. And your source file is with your code, so it is completely versionable and automatable. So it is DevOps ready, right? Configuration is a code. We're back to square one, but of course with a completely different quality of code and how it looks. So our DSL extensions are part of Artifactory plugins. Sometimes it's useful to look at the code to see how the objects are modeled. So you're more than welcome to go to JFrog Dev Jenkins Artifactory plugin, and we have here all the model that you can take a look at. And now let's talk. Let's shift gears and talk about Docker for a second, right? If you remember, this is one of the topics of our webinar. To get into why what we are doing is important when creating Docker, let's go back in time once again and talk about what we call is the age of binaries. Everything started in 2001 with the agile idea and the idea that we need to ship frequently, which kind of took us from, if you remember, the old ways of integrating once in 6 months or once in 4 months, and then having 2 months for integration, in the end of which once in half a year we had an artifact, which is our product. Now suddenly we have sprints, and we integrate and provide products much more frequently. Continuous integration, in about the same time, we have the CI server, which builds every night, and then later every commit, generating a set of artifacts which are our product. Continuous delivery, those artifacts now not only lie in the CI server, they actually go all the way to production, so they become our product, and it's very important to keep track of them. DevOps, configuration as code, virtual machine images, background boxes, more and more artifacts which are not only from development but also from ops. All the servers are now more and more of binary artifacts. Microservices, which means that every 12 lines of codes are now packed as their own artifact, going through continuous integration, continuous delivery, deployed on more and more virtual machines that are stored as binary artifacts. And then, of course, Docker. Every line in every Docker file generates a new file system layer, which is, of course, a binary artifact, and every change in this Docker file generates new set of layers. And now, looking at the future with IoT, every device in the world is going to get those updates in terms of binaries. This is what we call the age of binaries. Today, all the software development, both dev and ops, both Docker and IoT, are all about binary files. And let's put aside the IoT for a second and get back to the previous layer of Docker. When you live in Docker, everything is binary file, as I mentioned. Every line in Docker file, every change that you make, everything generates a binary file with its checksum associated to it, and then you have different kind of manifests that tie them all together into an image, into a running container, and everything. But you have tons of files that have meaning, which is not always clear to you. Right, so for example, you look at Docker layers, and we're going to take a look at that in our demo. They don't make much sense. All you have is a bunch of checksums that you are not even sure how they are related to each other and what's inside it. So the metadata that we spoke about, is extremely important, because this is what describes all those tons of binaries and how they're related to each other. And now, before we go on, let's see if you or indeed live in a Docker container. So I'm going to shoot another poll here to see how you use Docker, and we will draw some conclusions based on your votes as well. So this is kind of a different type of poll to see where are you in your adoption of Docker. Couple of more seconds if anyone else want to vote. Okay. Thank you for that, and let me share the results as well. So you can see here a very broad distribution of Docker usage, and the interesting part is, of course, the last one. So out of all of you, less than a quarter actually uses Docker in production, right? All of you, obviously, or almost all of you heard about Docker. All of you heard about Docker. Some of you played it with just a little bit. The majority do something meaningful with Docker, even playing with it or using it for non-production use cases. But only a fraction of people take Docker to production. And what we think one of the reasons is this opaque nature of Docker. This fact that you are not really sure what's going on inside all those tons of binaries, how they relate to each other. And this is exactly where the metadata that we spoke about can help. So let's talk about metadata in the age of binaries and how it is important. Right, so what we are talking about is finding the needle in the haystack of binaries, answering those three critical questions. What deployed where? You have tons of different environments which were created from this configuration as code, from images, from Docker images, from virtual machine images, and code is running everywhere. How do you know what is deployed where? How can you trace a binary to a source? Now you have a binary file. Someone came to you and said, okay, here is a Docker image and it misbehaves. Good luck troubleshooting. How do you even start doing that? And that's the use case that we are going to see during our demo today. The third one, how do you pick the artifacts that actually make sense to promote to production, but also to any other environment? How do you know what is the quality of the artifacts and how they correlate to each other? So answering those three questions is the reason why metadata is so important. And to work with metadata, you need to consider two aspects. First, how do you add metadata? So for example, we spoke about Jenkins. Tons of stuff is going on when the artifact is built. There are some environment variables, some dependencies are downloaded, some artifacts got created. How do you add all this metadata to the artifact? So it should be done automatically from the single source of truth, which is your CI/7. Custom metadata, right? You have this pipeline of promotion. Each step in the pipeline adds more and more metadata. How do you add that to your artifacts? How about describing the artifacts? Which platforms it targets, which architecture it targets? Again, you start to have multiple flavors of the same artifacts for different targets. How do you distinguish between them? Implicit metadata stuff, which is natural to binary files, like size, how many times it was downloaded, who uploaded it, permissions, etc., etc. This is about adding metadata, and now how do you consume this metadata? So remember, how do you answer those three questions using the metadata? So with Artifactory, it's fairly easy. We have Artifactory query language that gives you access to any metadata, both implicit and explicit, and you can mix and match. You can say, give me all the artifacts from a certain build that target a specific platform and was downloaded more than 3 times, and the size is more than 10 megabytes, right? So you can mix and match custom implicit and custom metadata in one query, and you can see here the reference. Basically, go to our user guide and search for Artifactory query language. You'll see a full reference with tons of examples of how to use Artifactory query language. In our example today, we're going to see this metadata in action by the example of tracing builds. So here is an example of the question that we are going to answer today. How do you know which Docker image contains your application file? Or how do you know what application file is contained in your image? So we're going to look at an image today and discover how do you go from a Docker image to an application file which is inside this image, and all that, of course, based on the information that we have from Jenkins. And now, with that, let's go to a demo. So let me close this one and fire up another sharing. that will show all my screen. This should be shared. All right. So I hope you can see my terminal now, and I'll clean the screen here real fast. And so, as you remember, we're going to look on tracing artifacts. And what I want to show you is I have a bunch of images here. And let's say someone comes to me and say, you know what, Baruch?
I don't know that.
Oh, sorry, that was Alexa jumping in. Here, you have this image, JFrog local Docker app latest, and it misbehaves. It came from production, it misbehaves, and I want to know what's going on. All right, so this is what we have. And in this case, usually without having this metadata that we are talking about, I don't even know where to start. Because not only the name is not descriptive, Docker app, what does it mean? The version is completely useless. Because if you use Docker latest version, it can mean latest at any point of time. It can be latest, which is latest now, or it can be latest from 3 months ago, because this application passed through the entire pipeline, then went to one of the production servers, then was running for 3 months, and now come back to me as latest. What do I know about it? Nothing, right? So there are some tools in Docker that help me troubleshoot it. I can use Docker inspect, for example, and then provide the image ID and take a look of it. Okay, you remember I mentioned bunch of checksums that don't make a lot of sense. Here they are. Let me just make it a little bit smaller so you will see more of it. Okay, here you go. Layers, bunch of SHA-2 checksums. What do I know about them? Nothing. Any better here? Well, a little bit. I know the repository. I know that it came from JFrog local. Well, I knew it from the tag as well. Here is a useful piece of information, the checksum of the image itself. I can copy it, and then I can go to my Artifactory. And if I'm lucky, and this artifact was built in Jenkins, which is connected with Artifactory plugin, and then deployed to Artifactory, I can do a checksum search and find this artifact. Okay. Now I'm in a better place. I already know the version. I know that it is actually Docker app version number 5 and not some anonymous latest. So I'm in a better place, and I can take a look of it. So I can go to my repository browser and take a look at this artifact. So, okay, much better. Docker info, these checksums of the layers are now explained. I can take a look of what they mean. So I know that the latest layer was running Tomcat. Okay, Java, good. And Tomcat means that we added some application file to it to run. And here it is. That's the add command. Well, kind of sucks. Kind of sucks because I have, again, a war file which is useless. I don't have a version here, and the name is pretty generic as well. Remembering that we can search by checksum, we can try and look for this checksum in our checksum search. So I will try to do that, and nothing will be found. Nothing is found because this checksum is not a checksum of the file. It's actually a checksum of a layer, which means a read-only set of file system that represents this file, not helpful. So let's go back to our image and see what else we can know. So examining the manifest here, I can actually see that I have another tab, a new tab, which is called builds. Now, build tabs is where the metadata about how this artifact was created lives. So we can see here that I have a project name now, and that's a project in Jenkins, build number, module ID, and the link to Jenkins itself. So let's click on it, and I will get to the build page of this artifact in Jenkins. Okay, now this is useful. First of all, I have the Git commit, and I can go to my sources and see the correlated sources of the Docker file that builds it. But also, I can, for example, examine the console output. Let's see, what do I have here? Okay, here we go. This is the file, web service var, that I actually added, and I can see where it comes from. We will see it in a different place. And here we can see how the Docker was built, successfully built Docker image. It was deployed to Artifactory. And of course, I have much more information now. My life is much easier. So before we are going to review this configuration of Jenkins and see and look at how Artifactory DSL extensions work here to provide this kind of metadata, let's keep looking at our artifact just a little bit more. From here, we can dive into what we call the build browser. The build browser is another view in Artifactory. It's right here. And it will show us the information that we collected from Jenkins for this build. So even if you treat your Jenkins as volatile CI server and you don't keep the builds forever, and a lot of people do that, and that's fine, the metadata that we saw now in Jenkins is still available, even if you take down this Docker container that runs Jenkins and spin out a new one without any content. The content is still saved in Artifactory with the artifacts, and that's the important part. So you can see here all the general information that you saw in Jenkins. You can see the published modules, and we have two of them. We have the Docker app itself, which is, I would say, a little bit less useful. So you see which artifacts were generated. All those are the new layers that are build generated, and the dependencies. And those all are the old layers that we kind of reused. So you can see here that we used Ubuntu from a Docker remote. That was our base image. And we used here a bunch of other layers. Well, again, it's hard to work with those layers because they're all named by checksums, and it's kind of, I don't know what to do with them. All the environment variables are saved here, and we're going to look at them in a second. And we can compare builds one to another. And again, we're going to take a look at this feature from another build. And this another build that I'm looking for is, if you remember, I'm on a quest of finding which Java artifact was contained in my Docker image, because this Docker image misbehaved. I need to find the source, and the source will probably be in the application file. So getting back to my published modules, I can see that there is another one, and this one only has one dependency. And this dependency is this file that I added to my Docker image. Now, because we have a universal artifact repository that we use both for Docker and for Java, both the Docker image that I'm examining now and the WAR file that was added to this Docker image, both were built in Jenkins that works with the same Artifactory intents. And that means that this WAR file is here. It is inside Artifactory as well. And I can see all the information about it right here. And now, as you already know, we need to go to the build browser. And when I go to the build browser, I can see here how this file was built. And again, I can go to the CI server. It will go now to another build. It will be create application WAR file build. And again, I can see the output. And here I will see it is Gradle. So I will see here all the downloaded artifacts, right? This is a compiled Java stage, and then all the uploads here, all the deployments, and everything is right here. And again, we're going to look at how this artifact is configured in just a couple of minutes. So let's go here to the build browser as well. This is already a familiar screen for you. All the general information, the published modules. In our example, this will be a multi-module Java build with Gradle. So here are the 4 modules, and this is our WAR file. It is right here. This is the guy, and that's the one that was added to Docker. Now we know it for sure. So we can examine all the artifacts here and see which artifacts, which dependencies were used, and the environment variables that were in fact active in Jenkins during the build. Let's say I suspect that the Java version that we build is wrong. Java 9 is out, maybe we should use Java 9 instead of Java 8, and this is what failed it. So I can search for Java and see, well, we use Java 8. I don't know if it has any effect or not, but this can be a very, very useful information for us. So that's kind of a big deal. The diff option, we can compare one build against another. We can say how build number 8 relates to build number 7. So I can see here, okay, those are the jars. Jars were changed because new jars were built, and some dependencies changed, interdependencies, that's fine, environment variables. So I can compare those two and see how they relate to each other. This is also very important. Now, all the concept of build info is about metadata that's passed from Jenkins to Artifactory. And it is passed by using the Artifactory Jenkins plugin. This is what gathers all the information. And once we gathered all this information, we build what we call a build info JSON file. So you can see here it contains all the information. And this is what is deployed in our Jenkins when we look at the console. So after our build is finished here, you can see that we actually deploy this build info here, deploying build info to a REST API of Artifactory. And deploying build info is exactly that, is deploying this JSON file that contains all of it. So we attach the JSON file to the artifacts in Artifactory, and it stays in Artifactory forever. And this is where your metadata resides. It resides by the artifacts themselves. So this is how we traced the information. Now let's go back to Jenkins and take a look at the configuration of the system, how it's configured. So first of all, as I mentioned, in your plugin manager, the Artifactory plugin is installed. Well, I probably need to update that to the latest version. The latest is 2.13.1, and you can see that it is installed from the normal plugin manager. In the general configuration, we configure how we use Artifactory. So you can see here that we have this Artifactory part of the configuration in which we provide the Artifactory server URL and configure default credentials. We can override those credentials per different builds if required. And also another part of configuration is build info proxy for Docker images. Now, this is needed to record which dependencies are used and which artifacts are produced in Docker. We see the traffic that goes in and out of Docker server, of Docker daemon that runs inside Jenkins, and know which artifacts are produced or consumed by our Docker build. So this is how you configure generally Artifactory. And now let's look at our build configurations. So first, as you remember, we start with building Java, and we can take a look at this file, at this configuration. So you can see here that we configured a couple of different parameters with defaults, so we can parameterize this build if we want to. So for example, we can select which Artifactory to use. We can select which Gradle should be used, to which repository we should deploy. What else? Should we use Xray to scan those images? And we are going to talk about that in a second. Should we clean the local cache before we start the build, etc., etc. And then, of course, we have the pipeline itself. So let me copy this script from here and paste it in some more display-friendly editor. This is Groovy. And now you can see here all the, how do I close the project view? Okay, no, I don't see it. Here, okay, never mind. It's still good. So you can see here that we configure a bunch of tools that work with Artifactory in order to create this build. So we configure a new Artifactory server, and then we configure a Gradle build. This is what we're going to use. We're going to use some project from JFrog training repository, and now we configure Artifactory. So we're going to use the Gradle that was selected from the properties that you saw earlier, the deploy, the resolve repositories, and we are going to create a new build info object with which we are going to work. We want to capture the environment variables, and then we can actually run this Gradle tool and build our projects. So once the build is over, if we publish the build info, and then if Xray scan is enabled, we're going to force Xray, which we are going to talk about in a moment, to scan this build and then return the results. And we can do a bunch of stuff with the results. We can fail the build if we want to, or in this example, we're just printing the results of the build. So here you can see how all those objects like Artifactory server, like Artifactory Gradle configuration, like the scanner results are the extensions that we provide to Gradle DSL inside our, Jenkins DSL inside our Jenkins plugin. And now let's look at another example. Let's look at our Docker build file, Docker image product. Again, let's look at the configuration right here. So it's pretty much the same. We have a bunch of properties configured, and here is our pipeline script. Again, taking it to more presentation-friendly editor. Again, I configure my Artifactory server. I configure the build info. Here I will use two of them because now I have dependencies which are builds as well, and that's the dependency to the previous Java build. And I will download the dependencies. Okay, so here I use something which is called a download pattern. Download pattern is a concept of Artifactory, and namely of the Jenkins plugin, that is going to download all the WAR files from this directory. And of course, we can use here, for example, and I think it will be even better, something like latest, right? That will say, take the latest release, because it is in the release local, and take the latest file out of it. And then we're going to save it into a WAR directory under web service.war name. And this is exactly what we're going to add to our Docker image. And once I download this the files that match this pattern, this download will be recorded in the build info as a dependency. And that's exactly how we saw the war file that was added as a dependency to the build info in Artifactory. This is extremely important. This is how you connect the dots. This is how we connected an artifact that was built in Java build in Jenkins to an image that is built in a Docker build in Jenkins. So we downloaded it and we recorded this fact of the download in our build info. And now we build a Docker image. So we are going to add this file and then build the Docker build and then deploy it and then push the Docker image to Artifactory and publish the build info. Again, we have some testing here, and then Xray kicks in, etc., etc. So this is the connection between Java and Docker. It is right here using the extensions of Artifactory plugin. Now, going back to our slides real quick, let's talk about this promotion mechanism and how do you decide that something is worth promoting. So we spoke about contributing metadata about the quality, and there are two more aspects except of quality that I want to talk in the time that is left. One of them is, both of them are covered by JFrog X-ray, and one of them is how do we manage open source licenses, right? So that's time about Dilbert comes to his manager and say, how do you, can you approve the usage of the software? And the boss say, go to legal. And the legal said, okay, here's a request form, email it to me, make sure to specify whether it's open source, approved open source. And anyway, this is a horrible process that people usually won't do, right? We cannot block the development by that. Sometimes, and I would say all times, we need to keep track of which open source licenses do we use. So the question is how we generate those licenses reports. There are tons of different plugins for Maven, for Gradle, for what's not. Most of them are horrible, inactive, broken, released 12 years ago, and not maintained anymore. Let's say you did manage to generate the report, and then the legal say, okay, you cannot use this license. What do you do? The release is still next week. How can you work with it now? Another aspect of licenses, of using third-party open source is security vulnerabilities. How do you discover those inside the open source component that you use? So those are important concepts, but it cannot be as the Dilbert that I showed you in the first slide. It cannot be blocking the developers from being creative. It should be something in the middle. And I think that JFrog has this middle ground of allowing the developers being creative, but still being in control. And the answer is JFrog X-ray. So you can see here how X-ray works. We analyze the artifacts in Artifactory and build what we call the component graph, software composition graph, that know exactly about each and every artifact in Artifactory. And then we can scan them for the information that you care about, which is security vulnerabilities, license images, and any other stuff that you care about. And you can do it when you feel right. For example, during the build, and that's exactly the example that you saw. We run this X-ray scan during the build, and then we let the developers do whatever they like and pick the artifacts that they like to work with, the dependencies that they like. But first, at time the software is built, we can get an alert about some artifact somewhere deep inside an hierarchy that have security vulnerability or license vulnerability. So we keep the developer creative. They do whatever they want, no firewalls between them and the productivity, and we catch the problems early enough. CI build is early enough, right? So this is kind of a big picture. The developer writes the software, deploys it, and then runs the build tool. The CI server pulls it from Artifactory, runs the build, and then Xray kicks in, analyzes the artifacts in the repository. If the vulnerability is found, then the build is failed. If the vulnerability is not found, the build is successful and the artifacts are promoted to a safer repository. And just to show you how it looks, I will open here JFrog X-ray. Let's see. Okay, that's not the correct password. I have it somewhere. I have it somewhere. I have it somewhere. Okay, I guess I'll need to take a look for a password. Here you go. That should be the password. Let's try it real quick. Yes. Okay. So I logged into JFrog X-ray, and it's about time to save it. And we can see the results of those scans that were part of our build. And you can see here, for example, the build number 5, and that's the Docker build that we looked, generated a lot of issues. You can see here all the issues and here all the information about it. So here, remember, we're looking at the Docker build. And in our Docker build, we see a vulnerability about Struts 2. For those of you who know, Struts 2 is a web framework that is used in Java. So that means that we now found a vulnerability which is inside our WAR file, inside our Docker image, inside our Docker build. That's like 3 or 4 layers down from what is being analyzed by Xray itself. And we can take a look of where it starts to is found by looking at those components. So we can struts. So we can search for struts as a Maven package here. Let's see if we can find any. Here we go. We can find 2 components of Struts 2, and both of them are critical. And let's see where this Struts thing hits us. We can do an impact analysis and see all the components that are vulnerable by this particular component. So here's web service. You now know that that's the WAR file that we were looking in. And it is inside a WAR file build. You can see that this is a build. That's the build that we examined. Inside a Docker image, inside 2 of the Docker images, inside the Docker layer, inside 2 of the Docker images that were built using the other build that were absorbed. So you can see here that 4 layers down, our Struts vulnerability was found when we are monitored the Docker builds with Xray. And it's the same with vulnerability, and it's the same with any other aspect. So, right, so that's the demo that you kind of look at. And before we go to Q&A, we have a couple of questions here that I will be happy to take. The good news are you can see the same demo that I showed you today with pre-configured Artifactory, Jenkins, Docker, Xray, and all the builds are already set up in the exact environment that I showed you. What you need to do is go to try.jfrog.com and we will spin up a virtual machine for you that has exactly the same demo that I showed you, both Artifactory, Jenkins, and Xray as well. And now one last poll while I will take the Q&A. What I want to hear from you is what kind of webinars are you interested in? So I will launch this poll, and while it is running, I will try and take some of your questions in the Q&A tab. If you have some questions, that will be a good time to go to Q&A and ask. So here is a great question. What happens if the vulnerability is found after a build time? And that's very, very possible. So we have two triggers in our system for vulnerabilities. One is we produced a new file. When we produced a new file, it might have one of the existing vulnerabilities, and we need alert for that. The other one is new vulnerability have been discovered on all the artifacts, and we need to see which artifacts are affected. And that's exactly where the unique scanner of Xray, a recursive scanner that knows how to go 5 layers or undefined number of layers into your build, is very, very handy. So let's say you didn't know about the Struts2 vulnerability, and now you heard about it with Equifax, it was discovered, etc. It will be automatically added to Xray database. We update our database multiple times a day, and then it will automatically do this impact analysis of showing you all the components that are affected. Not only Java components that have this vulnerability directly, but also all the other components that are affected by it. So let's say this artifact that have this vulnerability is a dependency for another artifact, which is inside a tar.gz file, inside the Docker, inside the Debian package, inside the Docker image. You will be alerted not only about the direct component that is affected, but any others that have this component in any level of depth. So this is pretty cool. Okay, let's see. Does this process work for .NET application build too? The answer is yes. So let me go here back to Xray, and you can see on the home page, I think, yes, all the supported technologies right here. So you can see that NuGet is here, so it works for .NET. NPM is here, and Bower is here, it works for JavaScript. Maven, Jenkins, obviously, Kotlin, and all the Java stack is here as well. Python, Docker, RPM, Debian, all the popular technologies are covered and work in exactly the same way. Okay, so I think that this is all for me, and we are just 5 minutes past an hour. So, oh, okay, here is the last question. Very quick one. Does Xray require its own dedicated server? Well, it's a bunch of Docker images, so you can run it on any hardware. It is kind of hardware heavy server, I would say, because it needs to unpack and dig into any artifact that comes into your system. And as you remember, there are a lot of artifacts. So it kind of CPU intensive and memory intensive. It's up to you whether you want to give it its own dedicated server. We suggest that you install it on its different hardware. Okay, what else do we have? Can we configure certain failures alerts with Xray to give feedback notification alert? Yes, absolutely. The alert mechanism that I showed you can trigger a bunch of events. It can send an email. It can integrate with any webhook, so it can give you Slack alert when Slack is not down. Or you can even trigger a custom JavaScript code that will run if alert happens. So that can be configured as well. Another question, few .NET packages are built as zip packages. Yes, and zip is supported by Xray as well. What is your recommendation for storing web applications in Artifactory? So yes, definitely a zip file, targz, all those are good techniques of storing web applications in Artifactory. More so, Artifactory can give you kind of staging environment for them, because you can run content from within zip file or targz directly in Artifactory. It's not recommended because it's both not very safe and CPU intensive, but it can be nice if you want just to take a look at your HTML file without unzipping it. You can do it within Artifactory as well. And of course, generic repositories have all the support in Jenkins pipeline, so you can deploy it from Jenkins. You can have all the metadata with all the build info, with this build of builds correlation. Everything works for zip files in the same way it works for Docker images or anything else. So thank you very much for your time, and I hope it was useful. Just a last reminder, try.jfrog.com will give you access to the same environment that I showed you today. And I hope to see you in the next JFrog webinars. Also come meet us in the meetups that we do in our JFrog offices and conferences across the world. So thank you very much, and bye-bye.